Okay, Assalamualaikum and hi everyone. So today we are going to learn chapter 2, first order of differential equation. So as you can see from here, we have three main subtopics. We have separable variables. Your second subtopic should be integrating factor. And the last one, you're going to learn about application of first order of differential equations. Okay, so here's the summary for this chapter. Chapter 2 is very simple, very easy actually, and very short. So you can score for this chapter. Here we have three main subtopic. We have separable variable, integrating factor, and application. So under application, there are four application: population, radioactive decay, Newton's law of cooling, electric circuit. Basically for application, we have to apply both of this. Okay, so now let's go straight to the notes here. So what is a differential equation? As you can see from here, is one which relates an independent or dependent variables with one or more derivatives. That means in one equation can be one or more derivative. Let's see example 2 here. We have d2 over dx squared. That means your second derivative. And we also have dy over dx. Okay, so this is what we call as differential equation. In differential equation, we have an order and a degree. So order is actually the highest derivative in the equation. Okay, let's see the second example here. You have your first derivative and you have your second derivative. Order means the highest derivative. That means this is your order. So your order is actually 2. Okay, what is degree? Degree determined by the power of the highest derivative in the equation. So this is your highest derivative and the power of this is 1. That means your degree is 1. Okay, so back to the first example here. The highest derivative is, we only have 1 here. That means the order is 1, and also the degree here is to the power of 1. So the degree is 1 as well. So for the third one, the order is the highest derivative. Here we have the first derivative. Here we have the third derivative. That means just look at this one. The highest derivative is 3. So the order is 3 and the degree is the power of the highest derivative. So the power here is 4. That means that is your degree. Okay, let's see number 4. So the order is the highest derivative. So we only have one derivative here, which is the first derivative, and the degree is 3. Okay, the derivative can be written as y double prime or y prime as well. So here we have the order is your highest derivative. We have the first derivative here and the second derivative here. So if we focus on this part, that means your order is 2 and your degree is to the power of 4. So that is your degree. Okay, for solution of differential equation, we have general equation, general solution, and particular solution. It is very simple. Just like your integral, you have indefinite and definite. Okay, for particular solution, you just simply substitute x and y into the equation and you get your particular solution. General solution, just in terms of x or in terms of t or in terms of r, depends on the question. Okay, so let's see how to solve differential equation by using separable variables. Let's say the question gives you dy over dx is equals to px qy. Okay, px qy is the expression. Contoh macam soalan ini ialah px, ini ialah qy. Okay, this is your px, this is your qy. Okay, contoh, saya bagi contoh. So, or maybe the question will give us dy over dx is equals to px over qy, or can also be dy over dx equals to qy over px. Okay, so what you have to do to solve by using separable variables is the first step, you have to separate variables x and y. X and y. That means, let's see this part here. Let's say this is your equation. So what you have to do is you have to separate dy y on one side and x on one side. Okay, here we have y, so you have to transfer y here. Dx you have to transfer there. So what we get is 1 over qy dy is equals to px dx. Okay, so that is your first step. Separate variable x and y. So the second step here, second step is very easy. You just integrate both sides. Okay, integrate both sides. So you will have integrate 1 over qy dy is equals to integrate px dx. Okay, alright, so first step, you have to separate variable x and y. Let's say if you have this is as your equation, so darab silang je lah. Okay, so the first step, separate x and y. The second step, just integrate both sides. Okay, so let's say example 1. Question give us y square dy over dx plus x cube. So we are going to solve this by using separable variables. So the first step here is to separate x and y. Let's put y on the left side, your x on the right hand side. Okay, so untuk senang, transfer dulu ini, negative x cube. Okay, buat satu-satu, there is no problem. Okay, no need to rush everything. Equals to negative x cube. And then what we have to do is we just have to move dx on the other side. You will have y square dy equals to negative x cube dx. Alright, so that is your first step. Okay, just separate variable x and y. So your second step is we have to integrate both sides. Just put integral sign. Y square dy equals to negative is a constant, you can put outside. Okay, just put integral sign and then integrate everything. Y cube over 3 equals to negative x4 over 4 plus c. Only put the plus c on the right hand side. No need to put plus c here. Okay, sebab kita hanya ada satu constant. If you put plus c here, plus c ni akan pergi sebelah juga. It's the same thing. Okay, so you don't have to put plus c on the left hand side. Just put your plus c on the right hand side. Okay, so that is how. So basically this is the answer. This is your general solution. Okay, very basic, very easy. So let's say example B. We have exponent negative x dy over dx is equals to 1 minus y square. Okay, the first step supaya tak salah pindahkan, tak salah separate kan, tak salah rearrange, just move dx here first. So your first step, we rearrange first. You should have exponent negative x dy equals to 1 minus y square dx. But here is x, here is y, here is y, here is x. So belum separatekan lagi. So what we need to do, y kena ke kiri, x kena ke kanan. That means here, this one we want to move here. That means bahagi 1 over 1 minus y square dy equals to this one, pindah sini akan jadi 1 over exponent negative x. 1 over exponent negative x dx. Okay, biasakan tulis 1 over. Jangan tulis dy over 1 minus y square. Okay, that looks very weird. Okay, kita tak integrate macam ni So jangan biasakan tulis dy bahagi dengan 1 minus y square. Kita bukan bahagi pun. Dy tu is just with respect to. Okay, so you know that this is actually exponent x. Okay, so we can just teruskan ke step yang kedua, which is integrate both side. So integrate 1 minus y square. 1 minus, sorry, square nya dekat luar. Okay, here square dekat luar. So we can actually use power rule. So kita boleh naikkan dekat atas 1 minus y negative 2 dy, which is on your right hand side, dekat situ ialah exponent x. Okay, integrate both sides. So on the left side we can use power rule. We will have 1 minus y negative 2 plus 1 is negative 1 divided by the power. Jangan lupa bahagi dengan differentiate dalam. That means differentiate 1 minus y, we get negative 1. Negative 1. Okay, tak perlu letak plus c only on the left side. Integrate exponent x, you still get exponent x. So simplify everything, you should have 1 over 1 minus y equals to exponent x plus c. So this is our general solution. Okay, so first step, separate x and y. Second step, just integrate both sides. Alright, so let's continue to the next example. Example C here. So we have x square root x square plus 1 minus y e y dy over dx is equals to 0. Okay, so first step is we have to separate everything. Separate y on the left side, x on the right hand side. Okay, so now apa yang kita boleh buat very simple. Kita pindahkan dulu sebelah sini. Make sure single kanan, single kiri. So that means we have x square root x square plus 1 is equals to y e y dy over dx. Okay, so what we can do is we move dx on this side, which is kalau kita susun balik, we will have y e y dy equals to x square root x square plus 1 dx. Right. Okay, so now all y's is on left hand side, all x's is on right hand side. So we can move to the second step, which is we can integrate both sides. Just put the integral sign. Nanti baru kita fikir macam mana kita nak integrate kan. Okay, for this part here, how are we going to integrate this? Y e y is one term, ey is one expression. Okay, obviously you cannot use substitution because you only have y here. So what are we going to do is we are going to use by part. Okay, while on the right hand side, we can use substitution. Okay, so now kita akan buat lah. So kita buat kiri dulu by using by part. So LPAT kita, so u is your polynomial. So we have y, so integrate dv is equals to integrate ey dy. So here your du, differentiate u with respect to y. Okay, bukan dapat dx dapat dy. V is equals to ey. So substitute into the formula. So integrate y e y dy is supposed to have u times v. So we have u times ey minus integrate v du. So we should have y e y minus ey plus c. Okay, so that is your answer for the left hand side. Okay, kita berhenti dekat sini tadi kan? Macam mana ni? Kita berhenti kat sini tadi kan? Okay, so on the right hand side, here's ni pula. So we are going to use substitution. Saya pakai pen lain lah, green. Okay, so by using substitution, we are going to choose our u yang dalam square root tu, but without the square root. So u is equals to x square plus 1. So your du is equals to 2x. Okay, as you can see from this equation, we have x dx. So here should be dx. Okay, so just make x dx as the subject. So you will have du over 2 is equals to x dx. Okay, so we can bukan simplify, tukar x dx daripada sini to the equation, to the question. So we will have integrate square root u, your x dx is actually du over 2. So the constant is 1 over 2. You want to integrate u to the power of 2. So we are going to end up with u 3 over 2 plus c. That means we have our u is x squared plus 1 power 3 over 2. Here we will have 3 plus c. Okay, so the final answer should be from here. So the final answer, we should have integrate y e y dy is equals to integrate x square root x square plus 1 dx. So here's the answer for this one is this one. So we will have y e y minus e y. Just ignore the plus c. Plus c just put on the right hand side only. And the answer for this one is this one here. Okay, include the plus c. We have x squared plus 1 power 3 over 2 over 3 plus c. Okay, that's it. Very easy. If you want to simplify, you can still simplify. We can factorize ey equals to x squared plus 1 power 3 over 2 over 3 plus c. Okay, so this is your final answer. This is your general solution. Okay, for solving differential equation by using separable variables. Okay, so let's try last question here. Copy. Okay. We have sin x over 1 minus y dy over dx equals to cos x. As I mentioned earlier, kita pindah dulu. Yang di bawah ni, apa ada di bawah, kita pindah ke sebelah. Okay, you don't need to like bebankan kepala kamu. Kita tenang-tenang saja. So here we have cos x times y minus 1 minus y dx. Okay, the first step is you have to separate x and y. Y on the left side, x on the right hand side. Okay, depends on the question actually. Okay, sometimes boleh juga x di sebelah kiri. So masih belum separate. We have x and dy together here, and we have y dengan x together on the right hand side. So what are we going to do is we have to move this to here. Okay, 1 minus 1 minus y dy. Okay, sebab kita pindahkan ini ke sebelah, dia akan jadi bahagilah. Okay, macam saya cakap tadi, elakkan tulis dy over 1 minus y. Sebab apa? Sebab tak cantik. Okay, ini bukan integral. Okay, dia integral je, but pelik lah, jangan tulis lah. So here we are going to move sin x to here, so that means we will have cos x over sin x dx. Okay, semua y dah di sebelah kiri, semua x dah di sebelah kanan. Let's just move to the second step, which is we are going to integrate both sides. Integrate 1 over 1 minus y dy is equals to integrate cos x over sin x dx. Okay, so mula-mula tengok, maybe you can change this to tangent x. But remember, you want to integrate tangent x. Okay, how are we going to integrate tangent x? We basically change tangent x to cos x over, no, cos, maybe kamu akan tukar sebagai cotangent, not tangent. Maybe you will change this into cotangent x. Okay, but how are we going to integrate cotangent x? We are still going to change the cotangent x to cos over sin x. So let's make it simple. You don't need to change. We just use substitution. So you will have u is equals to the denominator sin x, differentiate sin, we have positive cos x dx. So the answer here is we have 1 over u, because we take cos x dx as our du. Okay, so this one you can integrate by using, is it power rule? Nope, we have a linear here, so that will be ln 1 minus u. Jangan lupa divide by differentiate di dalam, so that will be negative 1. Okay, so here the same thing, integrate 1 over u, we have ln u plus c. So here we have ln 1 minus y negative. So change our u on the right hand side, which is cos x plus c. Here we have negative ln 1 minus y. Okay, so this can be the final answer actually. Sorry, your u is actually sin x here. Sin x. Okay, this can be the final answer, but let's see. How are we going to simplify negative ln 1 minus y equals to ln sin x plus c? How can we simplify this? Okay, this is extra. Okay, we are going to learn this more in the application subtopic. Okay, so let's move this to this side. So you will have ln sin x plus ln 1 minus y equals to negative c. Alright, just move this to here, move this to here. So ln, so properties of ln, rules of log. Your rules of log, kalau log, okay, log A plus log B. That means we can change to log A times B. So we will end up with ln sine x times 1 minus y, okay, equals to negative c. So what are we going to do is we are going to move ln to the other side. Okay, ln kalau pindah sebelah akan jadi apa? Yes. Apa yang yes? Exponent. Okay, that means we will have exponent negative c. Exponent negative c is just a constant. Okay, it's a constant. Kalau kamu tekan nombor, c is a constant. So exponent power constant, you still have a constant. We can just put as a, or sometimes the answer will put as big C. Anything pun boleh juga. Okay, so here the final answer can be like this as well. Okay, so the final answer can be written as this and also can be written as this. Okay, so that is how we are going to solve differential equation by using separable variables. So in the next video, we are going to learn how to find a particular solution by using separable variables. Okay? Okay.